Today we'll learn propositional logic. Proposition. Proposition is nothing but an elementary statement that may either be true or false. It can have no other value other than 0 or 1, that is either the statement is true or false. We can also refer the proposition as the sentences or the statements. For example, he is sleeping is a proposition as either the statement is true or the statement is false. So, if we say, where are you going is not a proposition as it does not result in true or false. Now, let's examine certain examples. 2 is an integer. Is the statement true or false? Is the statement true? So that is a proposition. 2 is not an integer. The statement is false, is a proposition. Is 2 an integer? Is not a proposition as being a question. Now the next is x to the power 2 is greater than 10, where x is an integer, is not a proposition as we do not know what the value of x. So depending upon the value of x, the result may be true or false. But as long as we don't know the value of x, we say it is not a proposition. The next, 5 plus 3 is just an expression, is not an proposition. Now, the propositions can be, or we can say the two propositions can be joined together with the help of connectors, and that makes a compound proposition. So for example, 2 is an integer and this is one proposition, and another is cat is an animal. So now if we join these two propositions, we say 2 is an integer and cat is an animal. So it becomes a compound proposition. We have joined these two propositions with the help of a operator AND. Like AND, there are other operators like OR and NOT. They may be used to join simple propositions to make the compound propositions. Proposition variables. A variable that denotes a proposition is called a propositional variable. A propositional variables can be replaced by propositions. In logic, the letter P, Q, R are used to denote propositional variables. In Boolean algebra, here we're going to discuss 5 different operators. The first is disjunctive operator. Disjunctive operator, it is also called as an OR. It is represented by a plus sign or an V sign. It means, this operator means if either or both of the inputs are true, the output shall also be true and false in other cases. That means, for example, let's say A represents I will opt for maths stream, and the B represents I will opt for computer stream. So with the disjunctive operator says A plus B means either I will opt for maths or computers or both. Below is the table given, that is, if P is true and or the Q is true, the result of disjunctive is true. If P is true or the Q is false, it's true. If P is false, Q is true, it's true. And if both are false, then the result is false. Next is conjunctive operator, that is AND. It is represented by a symbol dot or inverted V or an ampersand sign. When all the inputs are true, the output is true, otherwise, the result is false. For example, A represents I will opt for maths, and B represent I will opt for computer stream. Then the expression A dot B means I will opt for both maths stream and computer stream. Below is the table given reflects the output is only true when both the input or we say all the inputs are true. Otherwise, the result is false. Conditional. It is if then or also called as implication. It is represented by an arrow symbol or a greater than sign or a double line arrow. It explained as if one input is true, or we say if the left hand side is true and the right hand side is false, the result is false. Otherwise, the result is true. For example, A represents opt for maths stream and the B represents opt for biotechnology. Then A implies B means if I opt for math stream, then I will not opt for biotechnology. The table given below, the first case, P is true and Q is true, so the result is true. If P is true and the Q is false, the result is false. If P is false, Q is true, the result is true. And if P is false, Q is false, the result is true. Biconditional operator or if and only if operator. It is represented by a symbol double-sided arrow. Biconditional is explained as if both the inputs are true or both the inputs are false, the output is true. Otherwise, the output is false. That means, take an example, say, if A represent I'll opt for math stream and B represent I'll opt for computer stream, then A equivalence, the biconditional is also called as equivalence. So A biconditional B means if I opt for maths, I'll opt for computer stream also. Or if I'll not opt for maths, I'll not opt for computer stream. The result is true. So as the table indicates here below, P is true and Q is true, the result is true. And if P is false, the last case, if P is false and Q is false, the result is true. And in rest, the result is false. Last is negative, negation or the not operator. It is represented by the dash, the minus sign or a dash on a variable or a symbol as given here. It inverts the input value. Not is explained as if the input is true, then the output is false, and the vice versa. It takes only one input and one at one time. So if A represents, I'll opt for the math stream, then A complement, it is also called as complement. It represents the negative, that is, I'll not opt for the math stream. The truth table indicates if P is true, then P complement is false, and if P is false, then P complement is true. Now let's understand some of the terminologies used with propositional logics. Tautology. Consider the compound proposition P disjunctive complement P. From the truth table, it is clear that P disjunctive complement P is always true. Say as such compound propositions are called tautologies. As the table indicates, P is true and P disjunctive complement P results also true. But even if the P is false, the P disjunctive complement P results true. That means the output is true irrespective of what are the inputs. That is called as tautology. Contradictions. Consider a compound statement P conjunction complement P. From the truth table, it is clear that P conjunction complement P is always false. Such compound statements are called as contradictions. That is, whatever the input, the result is always false. Contingencies. That means the proposition that have some combinations of 1 and zeros in their truth table column are called contingency. That means for certain inputs in the output of the truth table, there are true as well as false value. Consistent statement. The two statements are consistent if and only if their conjunction is not a contradiction. For example, P represent it is raining and Q represent sky is not clear. Then the conjunction of these two statements P dot Q is not a contradict. Converse. The converse of the conditional proposition is determined by interchanging the antecedent and consequent of a given conditional. That is, that results into a new conditional. So we say P implies Q, then its converse is Q implies P. For example, if P it is raining and Q the sky is not clear, then P implies Q says if it is raining then sky is not clear. Its converse is Q implies P, that means if the sky is not clear then it is raining. Inverse. The inverse of a conditional proposition is another condition having negated antecedent and consequent. That is, if P implies Q, then its inverse is P complement implies Q complement.